Hello guys and girls. Now something I mentioned in my last video that I want to touch up is the electronic load and putting a load to a unit, power supply, any type thing, which we put this to a power supply. It's just a Westlow, it's a motor controller out of a treadmill. And we were getting actually almost 93.8 volts out of it at 7.8 amps. Yeah, so some serious 700 something watts out of this little thing. Doesn't even have a transformer or even a big inductor on it whatsoever. But yeah, just switching, that's cranking it out. One note on that, I have to warn you, I did check the AC ripple on that, and I was at 93 volts DC. The AC, I was getting a 60 volt AC ripple on that. So that's something to warn you about. I'm going to try to filter that with maybe a capacitor and maybe a diode, couple diodes maybe, to try to trim that, clean that up a little bit. But that's in the future. Right now, loads, right here, electronic loads. And the simplest thing you can do for an electronic load is just the simple toaster. Bang, 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 right? And the way you do it, real simple, you just hook it right to the power. Now the ground on this is actually nice to have, and it's voided if you're using an isolation transformer. It's going to be voided unless you physically went in your isolation transformer and linked it through. But on this, it's going to be hooked up, and we're going to hook it up, and it should read, yes, it reads mega ohms, OL, open line, over limit, whatever you want to call it, out of limit. Out of bounds. But you gotta turn it on. That's all it is. You gotta turn the timer on, let the timer run, and you can see with this one it's 17.8. It kind of depends where you put it in the range. It really doesn't vary that much until you click it to broil. As you'll see right here, it'll bounce, and it bounces up to 30. So I think I was wrong in my video. I said it the other way. I can't remember. Don't remember much these days. Actually, I get couple different readings: 14, 26, 22, 22, 2. Now, with doing electronic load, you got to be careful. First off, this is not going to work if it's off. So no matter where this is, it's just going to... Oh, wait, how is that still... Yeah, this one's off. Which some of them click to off or it's on minimum. You got to just make sure it's on. The light might not come on, but you're still putting that DC, that heat, through the resistance units, which are these. In fact, this stupid thing. You can't just sit the frick still, huh? Gotta be a S, O, a B. That's all these things are, is right here. Inside of this one, like I said, there's two of these. And as you can tell, I collect them, and on each one, because they're used, you can see there's 11 ohms on that one, end to end. 10.8. This one's 8.9, and I got one hanging here because I'm going to cook that one. That one's actually probably getting ready to blow. That's at 240 ohms, and it's the exact same thing as this. I just hooked some wire to it and hung it because once I hook a load to it, it's going to get hot. Also, I got, you could call these kind of wire round resistors. They're really not. They're actually heater elements. Come out of something old that I found. What is it, 17.7 on this one, and this one I got the wire already wrapped, so I just unwrap it and hang it, and as long as it's hanging, it can get cranking red hot, and it ain't gonna burn through something or burn me, because no one wants to see that. There's enough trouble going on around here. So, just for instance, to give you some electronic loads, that's what you're looking at, because that's something that really confused me when I was trying to learn electronics was, oh my god, I gotta make a load or try to DIY one or this or that. And I just come across the simplest things. I just try to keep stuff simple and stuff that's simple for you guys to find. I imagine, worst case scenario, go to any thrift store or that, and you'll find for 10 bucks you could probably get one of these. I mean, this one's cheap. Usually you see them, they got 4 of these elements. And like I was saying, you audio guys, I was getting on one of these readings, what was it, 22? You cut that in half, it ain't in half, but I know you audio guys, you get all excited about 8 ohms. I got 8.9 ohms on this one. So technically I can hook audio amplifier up to this don't need to blare the music to test something for an hour, and let it burn off in this. If you get a couple of them, string them together. How you string them is definitely going to change. In parallel, you're going to cut it in half. If you series it, you're going to double. So you got to be careful how you do that. I hope I said that right. You might want to double check. I always seem to get flustered. So that's about how that goes. And then these got different values, 13, and I just keep these kind of bouncing around, probably just so I can cut myself and cry. But then this one I can cut to whatever I want. If you shorten it up, it's going to obviously make it a smaller resistance, which is going to make it less than 26, any more that I take off of it. And just getting to that same thing. Now, something that you guys see all the time probably. There, simple. You know what that is, right? That's an iron. So iron here, you just hook on. Here's where the two terminals hooked up. Now this one has a lot of windings in it, and I was getting 1 mega ohm, and if I believe, what? Where was I hooking it up to? I have written on there 1 mega ohm, so I'm not lying. Yeah, that's bouncing around. I'll have to recheck that, because you also got to watch, if it's bouncing around like that, you're also fighting an impedance, which is your capacitance is also, and that's a totally different formula than your voltage, because basically, if you're doing a simple load, you're looking for your voltage, you're probably looking for your amperage, something to dump off your voltage into and test out your power supply to find where your amperage is at or what your output is. And in doing that, you're going to want something that isn't bouncing around and that is reliable. And on the other hand, you got to be careful now when you start dropping down in the ohms. You got to remember, you're going to raise the amps up, and you can, dropping it down, oh, I want to see what this thing really puts out in amps. Well, you got to remember, that's stress on the whole unit, on everything. And in mine here, we found real quick that we shot this with the temperature gun, that this was getting real hot, this resistor here, when we were getting around 8 amps, 7.8 amps at 90 some volts. So you got to be really careful there, and it's, that's pretty high DC electricity. Be super careful, and if you don't know what you're doing, just learn it. Just take the time to learn it. It's actually a lot of fun. This is a big dumb one that I have just laying around. It's just because it has big values. I can set it like this and just let it burn off on something and just cook away in heat. And some other nice ones here. Again, audio guys might... These were just hot plates out of, I think the George Foreman, actually. I'm almost positive. These are top and bottom. They just were wired in like this, overlapping each other. And 20 ohms a piece, and you parallel them together, and you got 10 ohms, That's almost 8 ohms. And this one's 22. This is out of a coffee maker. The water runs through it, and there's a heater element in here. It's sealed, and that pumps through it. So, again, just simple things that you can do. And as you seen earlier, too, this one is a heating element that I shorted out, and sparks flew in the one vid. We got 430K from here to here, and then from this to the end is 10 mega ohms. So this is kind of a nice big range one if I needed it. And there's other things you can do too if you want to go variable. Well, this one, if I connect, now this is a switch here, so I want to avoid the switch. That just complicates things. If I go here to here, or I could just pull these off, and then I can connect to them with being a little bit safer. I got 38 ohms. Well, I figured that if there's a wire, was there a wire? Yeah, if I clip it up in the top here, I get 20 ohms. Or maybe it's here. Yeah, it's right here, right in the center here. On this one, just the way it's wound. 20 ohms, and then the further back I come to the anode or cathode side, which is your positive or negative side, the lower that number is going to get, or the bigger it's going to get on the opposite side, depending on how you got it. I'm talking pull the wire right out and clip right to it, right on here, So that's, again, wherever you find it and mark it out. And this is made with fire retardant stuff. I said retardant, all right? And again, it's a hot plate, That's all it is. But it's made to be burned off. And that's what's the nicest thing about this right here. is, as you can see, it's written right on it, 1150 watts. That's what it's sold. Right on the bottom it says, right in here. I should highlight it right there. 1150 watts. So safely you can plug it in the wall, crank it all the way up, and it's putting out safely contained in this box with nothing on top of it, safely 1150 watts. That's a lot of watts. You know, that's crazy watts. Now, you can pump a lot of watts into this and just let it burn right off for you. So that's something, again, you can use, and it's even more variable if it's got, instead of 2 of the links in it, it's got 4 of them. It just, again, you can take one out. If it was 24 and you let's see, figure out 24, and you take one of the links out of the 24, that's going to be 6 apiece. You're going to be down to 12 is half. 18, is it? I don't know. It's too early for me. 18-ish, we'll call it. But if you cut it right in half, you're 12 ohms, you know. If you got, I don't know, whatever you're looking for. And here, just the last, we got through them. I got that. That's done. And the real simple load, too, that you can probably have if you're into any type of electronics, is the simplest, is just right here. Just your simple motor. Just take your power supply, pop it on. Now this one's 100, you can see it's 100 volts rated right on the side. Let me zoom you in so you can see it. I wrote it right on it. Upside down, of course, as usual. But right there, it's spinning away. Just burning off energy. Just something to cook off energy if you need it. Cooking off wattage, you know. And there's the last thing. That's just another, it's a heating rod for something. Again, that's marked 40. So just a whole bunch of things. I said I'd talk about it quick, so I wanted to just bring it up quick, knock the video out, just give you a wide variety of the different types of different electronic loads that are out there. And as you can see, I'll give this, I'm at 10 volts, 400 milliamps. I'll crank it up. And I'm current limiting, or I'm not current limited, I'm actually voltage limited. So by turning the voltage, I'm actually turning the speed up. Now, when we started this video, I was at 10 volts, at whatever I said there. Now it's 16 volts, and look at just what, we'll get it up to, try to get an amp out of it. I gotta bring it back down and current limit it. Keep going the wrong way at the darn dial. There we go. Just hit almost an amp. There it goes. At 30 volts. Now the amperage kicked back down as it boosted up. But see, that's kicking it right along good. It ain't hurting nothing. It's DC running through it. That's what it's made for. 100 volt DC. Got to make sure it is DC or AC. DC, you can get away with a lot, running a lot of different things. But there is things that are AC specific, and they specifically need that AC chop. That's what runs them, the pull shifts in it, that runs it right. With these, I like to totally disconnect it quick because of the, basically that magnetic field that's built up. It builds up, and you shut your power supply off, it still collapses, and it can collapse and maybe blow right through into whatever you got protecting. You don't know what some of these power supplies have running them, you know. Especially, that's just a cheapie, just a get her done jobber. So I always unplug them that way that it can collapse and just burn it off inside, and it'll dissipate on its own, instead of pulsing possibly back through and blowing out, who knows, my protection diodes or something. I imagine they're not real bulky, you know, on the output of theirs. The unit here, I have checked, and there is actually some protection, but I know it's not much. And then one last thing for show here, once I get this thing the other way, there. And here's just a dumb coil. and we'll put some heat to it and see what it does. We'll melt it down. We'll get some good heat. I'm gonna current limit it. Oh, one other last thing I forgot, and you gotta just always remember your voltage. You got an old dead old battery that just never takes a charge right. Just throw, as long as you're not throwing, you know, like 40 amps into an 18 volt battery. If it's 18, you can burn off 20, you know, put 3 amps into it at 20 volts. It ain't gonna hurt. You know, it's just gonna dissipate it anyway off in heat. And make sure you're just feeling it ain't getting too hot. And you can burn off a lot of energy. Them batteries will just soak it right up. Eventually, in time, you know, they're just going to drain it off. But, hey, maybe you even use it, you know, from the dead battery. But them work also very well for dumping off if you just want to lose energy into something. But let's get this thing, let me make sure I got my limit. I want to current limit it quick. Come on. We'll give it 3 amps right off the bat. We'll see. Sometimes this power supply doesn't act the way I think it should. So we're at 15 volts right here. It's current limited at 3 amps. And obviously it's not going to be able to handle this. So let's see what it does. It should start roasting. And it's getting hot. It doesn't like it at all. It should be triggering a little plunger that shuts the thing off, but it doesn't. It needs more amps. More amps, and it definitely ain't 3 amps. Like I said, that power supply doesn't want to put that through it. Alright, we're getting about 1 amp through it. Oh, it's starting to smoke. It's really nothing fabulous here. We're just doing a little smoke show. Burn it down, burn it down. Burn it down. Oh, now it's cooking. Now, oh, I don't want it to burn me. See, now it'll sit here and roast until it finally burns through one of them tiny little wires and shorts out. And I don't want it falling. And it smells. It smells like dog. Woo! And it popped. That's when it finally broke the connection, is right when it popped. It pick, blicked. That's about it, guys. Hope you enjoyed it, and I just wanted to drop something. Just try to help make life a little easier for everyone out there. And hopefully this helps someone out. Got any ideas or that? Anything that can help me out? Leave in the comments. I have no problems with that. Any improvements you think I need, let me know. I won't take offense to anything. Always willing to learn. And always thank you very much for giving me a second even of your time. And if you waited this long, I hope you're still awake. And you have yourself a great week and weekend. Thank you.